13.8 billion years ago, the universe was born in a moment we call the Big Bang. In that first fraction of a second, all the energy and matter that would ever exist was crammed into a space smaller than a single atom. It was a point of infinite density and temperature, a singularity. From this single point, space itself began to expand, carrying everything with it. This wasn't an explosion in space. It was the explosion of space. Every particle, every force, every law of physics we know today was forged in this primordial crucible. It's a moment that defies our everyday intuition, a beginning so extreme it's almost impossible to comprehend. But it's where our story, the story of everything, begins. Imagine a pencil balanced perfectly on its tip. The slightest nudge, the tiniest vibration, and it falls. In its earliest moments, our universe was in a similar state of precarious balance. It was perched on a knife's edge between two catastrophic fates. If the expansion was just a little too slow, gravity would have immediately taken over, pulling everything back together into a big crunch before the first stars could even form. On the other hand, if the expansion was just a little too fast, matter would have been flung apart so quickly that galaxies, stars, and planets would never have had the chance to coalesce. The universe would have become a cold, empty, and barren void. We exist because, against all odds, the expansion rate was just right. This incredible fin-tuning is known as the cosmic balance problem. The initial conditions of our universe had to be set with an almost unimaginable precision. Think of it this way. If you were to fire a cannonball and wanted it to travel across the entire observable universe and hit a target just 1 inch wide, you would need a level of accuracy far less than what was required for our universe to exist as it does. The parameters had to be perfect to 1 part in 10 to the power of 60. That's a 1 followed by 60 zeros. Any deviation, and we simply wouldn't be here to wonder about it. This is one of the deepest mysteries in cosmology. Was it a sheer, unbelievable coincidence? Or is there a deeper reason for this perfect balance? So, how did the universe escape this immediate collapse? The leading theory is called cosmic inflation. In the tiniest fraction of a second after the Big Bang, the universe underwent a period of hyper-accelerated expansion. It grew exponentially, ballooning from subatomic size to larger than a grapefruit almost instantaneously. This incredible burst of growth acted like a cosmic reset button. It smoothed out the initial chaos and flattened the geometry of space, effectively setting the expansion rate to that critical, perfectly balanced value. Inflation took the universe from that pencil-on-a-tip state and placed it gently on a stable foundation, giving it the momentum it needed to overcome its own gravity and begin the long, slow expansion that continues to this day. But inflation also planted the seeds of everything we see around us. On the smallest scales, the universe isn't smooth. It's a roiling sea of energy, with quantum fluctuations causing particles to pop in and out of existence. During inflation, these tiny, subatomic fluctuations were stretched to colossal, astronomical scales. The regions that were slightly denser became the gravitational seeds around which matter would later clump together. These microscopic ripples from the beginning of time grew over billions of years into the vast cosmic web of galaxies, stars, and planets. Every structure in the universe, including our own Milky Way, owes its existence to these quantum jitters in the first moment of time. The universe is governed by 4 fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. The precise strength of these forces is another piece of the puzzle. If gravity were slightly stronger, stars would burn out too quickly for life to evolve. If it were weaker, stars and planets might not have formed at all. If the strong nuclear force, which holds atomic nuclei together, were just a tiny bit different, the only element in the universe might be hydrogen, leaving no building blocks for planets or people. The relationships between these forces had to be perfectly calibrated. This delicate dance of forces ensured that a complex and stable universe could emerge, one with a rich variety of elements and structures. For every particle of matter, there should be a corresponding particle of antimatter. When they meet, they annihilate each other in a flash of energy. In the early universe, matter and antimatter should have been created in equal amounts. If that were the case, they would have all canceled each other out, leaving behind a universe filled with nothing but light. But that's not what happened. For some reason, for every billion antimatter particles, there was 1,000,000,001 matter particles. After all, the annihilation was over. That tiny remnant of matter was left behind. Everything we see, every star, every galaxy, you, me, is made from that leftover fraction. This slight imbalance, this cosmic victory of matter, is the reason we have a material universe at all. For billions of years, the expansion of the universe was slowing down as the mutual gravity of all the galaxies pulled on each other. But about 5 billion years ago, something strange happened. The expansion started to speed up again. Scientists have named the mysterious cause of this acceleration dark energy. We don't know what it is, but it seems to be a property of space itself, an anti-gravitational force that is pushing the universe apart. Dark energy now makes up about 70% of the universe. It's the dominant force on a cosmic scale, ensuring that the universe will not collapse back on itself in a big crunch. Instead, it seems destined to expand forever, growing colder and darker. The result of all these finely tuned parameters, these lucky breaks and cosmic coincidences, is a universe that can think, a universe that has evolved matter complex enough to become conscious. Through us, the universe is able to look back on itself, to contemplate its own origin, its own mechanics, and its own destiny. From the Big Bang to the formation of stars, from the synthesis of heavy elements to the evolution of life on a small blue planet, a chain of events spanning 13.8 billion years led to this moment. The atoms in our bodies were forged in the hearts of dying stars. We are, in the most literal sense, stardust. We are the universe's way of knowing itself. This chain of events connects everything. The quantum fluctuations from the first picosecond are imprinted on the cosmic microwave background radiation, the afterglow of the Big Bang. Those same fluctuations grew into the galaxy clusters we observe today. The laws of physics that govern the largest structures are the same ones that operate inside the smallest atoms. There is an unbroken thread that links the beginning of time to the present moment. Looking up at the night sky is like looking back in time, seeing light from stars that has traveled for thousands, even millions of years to reach us. We are deeply and fundamentally connected to the cosmos, a part of its grand, unfolding story. What if things had been different? What if the universe had collapsed back on itself a second after it was born? There would be no time, no space, no stars, no life. Just a fleeting singularity, a cosmic what if. The universe would have been a failed experiment, a story that ended before it even began. The fact that it didn't collapse, that it survived and flourished, is perhaps the most remarkable fact we know. Our existence is a testament to the universe's stability, a consequence of a series of events so improbable they border on the miraculous. We live in the timeline that worked, the one that made it through. So, why didn't the universe collapse? The answer isn't a single thing. It's a combination of inflation setting the perfect initial speed, the fundamental forces having just the right strengths, a slight asymmetry between matter and antimatter, and the eventual emergence of dark energy pushing everything apart. It's a grand conspiracy of cosmic coincidences. Whether this is the result of pure chance in an infinite multiverse of possibilities or a sign of some deeper unknown principle remains the big question. It's what drives astronomers, physicists, and dreamers to keep looking up, to keep asking why. The universe is not just stranger than we imagine. It is stranger than we can imagine. The story of the cosmos is the ultimate story of survival, of balance, and of wonder. It's a story we are still uncovering, one clue at a time. If you've ever felt a sense of awe looking at the stars, you're connecting with this incredible journey. Thank you for exploring this mystery with me. If you enjoyed this journey through space and time, consider subscribing for more explorations into the biggest questions of our universe.